Hello there, and in this episode, we're going to look at the very first principles of probability. So we're going to start by looking at randomness and fairness. So if something is fair, it means that each outcome is equally likely, and a dice that is fair in each of a number of then each of the numbers is equally likely to appear. So if you roll it, you're just exactly the same chance of getting any of the numbers 1 to 6. Same with a coin. If a coin is fair, then it's equally likely that you'll get a heads or a tails. Now, a coin or a dice that is not fair is called biased. And random events are ones that each outcome is uncertain. So, for example, if you roll a normal 6-sided dice, then the result could be a 1, a 2, a 3, or 4, or 5, or a 6. That's completely random. But something like who's going to win a football match won't be random because the teams will be better, one of the teams will be better than the other. Even though there is an element of chance involved, it's not a completely random event. Think about that in some sort of context. Say you've got a dice and you roll 600 times, and the number 4 appears 12 times. What we can say about that dice, or we can probably guess about that dice, is that first of all, it's not a fair dice because only 12 out of 600 times you got a 4, and also the probability is probably skewed towards landing, skewed away from landing on a 4. By that I mean it's biased against landing on a 4. So thinking more about randomness in events, a penalty shootout could be seen as random, although you could also say there's an element of skill involved, so not completely random. But something like rolling a dice is completely random. Now, if all the possible outcomes of an event are listed in order, what you can do is you can assign probabilities to each of those events happening. So, and what you need to know is that if you add up all those probabilities, then they will add up to 1. So if you list all possible outcomes and they're all included, and also only one outcome can happen at a time, then they will add up to 1. So to say, for example, if you've got the probability of me finishing my glass of water in the next 5 minutes, and also the probability of me not finishing my glass of water in the next 5 minutes, if you add those two together, they will be equal to 1. That's because that's all of the probabilities involved in me finishing or not finishing my glass of water. And also, they can't both happen. So I can't both finish and not finish my glass of water. So again, if we think about that in an example, so if we've got the probability of rolling a 5 on a biased dice, if you roll a 5 on a biased dice, and the probability of that is 0.4, you need to be able to work out the probability of rolling any number which isn't a 5. So first of all, you know from the question the probability of rolling a 5, and you know from what we just talked about that the probability of not rolling a 5, when you add those two together, it will be equal to 1. So the probability of rolling a 5 plus the probability of not rolling a 5 equals 1. Now you know the probability of rolling a 5 was 0.4. So what you can do is you can say, okay, the probability of not rolling a 5 is 1 subtract 0.4, which gives us 0.6. And remember that the probability of all possible events added up together will give you 1. Now, you also need to know about something called relative frequency. Now, the relative frequency for each outcome can be calculated after a probability experiment. Now, what a probability experiment is if you do something like you roll a dice 150 times, and you see how many times it lands on a certain number out of how many rolls you do in total. So what we can do is we can say to work out this thing called relative frequency, we take the number of times the event happened. So say we were looking to roll a 1, the number of times a 1 was rolled, divided by the number of trials, so how many times you did it. So number of times I rolled a 1 divided by how many times I tried to roll a 1. And then if we do that, we can work out what's called the relative frequency. So say we rolled a dice, I'm going to roll it 150 times, and I got a 4 in 25 out of 150 150 times. So to calculate the relative frequency, I'll do 25 divided by 150, which would be equal to 1/6. Now, the relative frequency of an outcome in one experiment can be used to calculate what we call the expected outcomes in future experiments. So if we know the relative frequency, we can times it by the number of times we're going to try something, number of trials. So go back to the same example, the number of times I'm going to roll a dice, and that will give me the expected frequency. And by that, I just mean how many times I expect something to happen if I try it however many times. So I can say if the frequency was 1/6, like it was before, and I want to do it 600 times, I can expect 1/6 times 600 of times that number is going to come up. Now, if the relative frequency of a result is fairly different from what you'd expect from a fair dice or coin, then you can conclude that the dice or coin is probably biased. Otherwise, you can just conclude that it's a fair dice or coin. The reason we put probably biased in there is because it could just be a random chance that actually you got only 12 out of 100 times you got a 6. So it might just be an element of randomness in there, but we can say it's probably biased. Now, what is the relative frequency of picking a red ball from a bag if a red ball is pulled out of a bag 100 times in 400 trials? Now remember, the relative frequency is the number of times you succeeded in what you're trying to do divided by the number of times you tried to do it. So 100 divided by 400 will give you 0.25 as the relative frequency. And remember, the formula for expected frequency is the relative frequency divided by the number of trials. Now, a scenario for you. A dice is rolled 600 times. The number 1 appears 572 times. What we can say about that dice is, first of all, it's probably not fair, and also that the dice is probably biased towards landing on 1. Let's look at a similar question to one we looked at earlier. So if you've got a biased coin and one side is heads and one side is tails, the probability of getting heads is 0.8. You need to be able to work out the probability of getting tails. So remember, the probability of getting heads plus the probability of getting tails will be 1. So we know that the probability of getting heads was 0.8. So we can work out the probability of getting tails by doing 1 take away 0.8, which is 0.2. We know that because the probability of all possible events happening added up together will be equal to 1. Now, another example, thinking about expected frequency. So an experiment showed that the relative frequency of getting a 2 on a biased dice is 0.6. How many times would we expect to get a 2 if we rolled the dice 100 times? Well, remember, the expected frequency is equal to the relative frequency times by the number of trials. So if we substitute values in, the expected frequency equals 0.6 times by 100, because we have 0.6 as the relative frequency and 100 is the number of trials. So your expected frequency would be 60. That just means how many times we'd expect to roll that 2 if we rolled it 100 times. And the last question for you, if we had, let's say we had Mars bars and Snickers bag, and you wanted to pull out how many times, or what the relative frequency would be of you pulling out a Mars bar, and you pulled out 100 Mars bars out of 400 trials or 400 attempts, what would you say the relative frequency was? Remember, it's the number of times you were successful divided by the number of times you tried. So it'd be 100 divided by 400, which gives you 0.25. So that's the end of our first episode looking at the basics of probability. Join us again next time to look at more probability stuff that you can learn for your exams.